In this section, we're going to look at some reactions we can use to get to amines by reduction. And in terms of what a reduction is, and this is a reaction that we've seen before in various circumstances, but essentially a reduction is an increase in the number of carbon-hydrogen bonds and or a decrease in the number of carbon-oxygen bonds. And that's a very kind of simplified and loose definition of reduction. So what we're going to be trying to do here is start with some functional group. We're going to do a reduction, and we're going to end up with an amine. And the functional groups that we can actually reduce to get to amines, these include nitro groups, amides, and nitriles. And what we're going to find is that effectively when we're doing reductions, we're adding hydrogen to these molecules to do the reductions. So let's look at each one in a bit of detail. A common way to get to an amine is through the reduction of a nitro group. So let's take a look at an example. Here we have nitrobenzene, and to it we're adding the reagent hydrogen gas and the metal catalyst palladium on carbon. And this is a familiar reagent. We used H2 with palladium on carbon to reduce double bonds previously, where we added H2 across the carbon-carbon double bond. Well, in this case, we're actually using the same reagent to reduce the nitro group. And effectively what we're going to be doing here is adding hydrogen to the nitrogen and losing oxygen from the nitrogen. So at that nitrogen, we're increasing the NH bond count, and we're decreasing the NO bond count. So what we're going to end up with as our product, that nitrogen that was part of the nitro group is still there. But now instead of the two oxygens on it, we have two hydrogen. And those hydrogen come from the hydrogen gas. So what we end up with is an amine product. This doesn't have to be a nitro on a benzene ring. It can be other nitro groups as well. Here's 2-nitropentane. If we subject this to the hydrogenation conditions, that NO2 is going to get reduced to NH2. So again, we have an amine product. We can also yield amines through the reduction of amides. So remember, an amide is a carbonyl with a nitrogen, and it could be an NH2, or it could be an NR2 if you have carbon groups, something along those lines. So for this, we're going to use a different reducing agent. We're going to use lithium aluminum hydride. So let's take a look at this amide here that we're going to reduce. Our reducing agent is lithium aluminum hydride. And if you want to see a little more what that looks like, we can draw it out. So we have lithium plus and 4 hydrogen on an aluminum with a negative charge. And what that aluminum hydride essentially does is it provides a source of H-. And that H- is what adds to this amide to do the reduction. Step 2, where we add water, this is what we often call a workup step. So this could be aqueous or acidic. And this just quenches these strongly basic reagents like lithium aluminum hydride. You may also see lithium aluminum hydride abbreviated as LAH. So if it's written like that, it's the same exact thing. So in this case, what happens is we're going to focus on the carbon of the amide. That's where the chemistry is taking place. And the hydrides, two of them actually end up adding to this carbon, and you lose the oxygen. So that carbonyl was replaced with the 2 hydrogen. And this also fulfills our definition for a reduction, because at that carbon that I've highlighted in green, this carbon right here, the net result is that we have decreased the number of carbon-oxygen bonds. We've increased the number of carbon-hydrogen bonds. So that is in fact a reduction. Now in this video, we're not going through the mechanism for how this happens, but through nucleophilic addition, this hydride adds to that electrophilic carbonyl carbon. That happens twice, ultimately replacing the oxygen with the hydrogens. Now this doesn't just have to be NH2. This can be any type of amide. So let's look at one more. Let's say we have a methyl and an ethyl on the nitrogen. Right, if we do an LAH reduction of this, right, so I have my LAH in step 1. Step 2, again, is just a workup to quench everything when you're finished. I used acid instead of water. It doesn't really change anything. What we care about is our primary reagent, which is the lithium aluminum hydride. So what that does is, again, it reduces off that carbonyl of the amide. So then we're left with this product. And in most cases, I would probably just leave those hydrogen implied. Ultimately writing the product like that. Lastly, we can reduce nitriles to get to amines. And this is very similar to the amide reduction in that we're going to use LAH again. That's our reducing agent. So let's draw out a nitrile. So let's take this, add LAH, so that's our hydride source, and I'm going to do an acidic workup. All right, so this is actually going to require essentially reduction of both the carbon and the nitrogen. And it might even help to visualize if we draw out the CN bond. So it's carbon triple bonded to a nitrogen. We're going to focus in on both the carbon and the nitrogen here. When we do the reduction, what happens is the LAH provides hydride, which reduces the carbon. So in the product, that carbon gets 2 new hydrogen added to it. Here's the bond to the nitrogen. And that nitrogen ultimately picks up its 2 new hydrogen from your aqueous or acidic workup reagent. So that donates protons to get to NH2. So we reduced both the carbon and that nitrogen. During the process, the CN triple bond became a CN double bond, or a CN single bond. And this is another case where you might clean it up a little bit. Leave that carbon and the 2 hydrogen implied, and just draw it as your amine like that.